Here is Siberia. Stand upon 540 million years of history, and beneath, a new ocean tears itself into existence. This 5 million square mile archive records planetary autobiography in basalt and ice. Rifts split continents at measurable speeds. Volcanoes exhale steam from Permian-age magma chambers. Limestone cliffs preserve the moment life learned to build skeletons. Siberia's essence emerges through violent contradiction. Northernmost deserts meet southernmost tundra within miles. Ancient astronomers tracked stars from mammoth steppes. Geysers hurl boiling water skyward, where winter fractures steel. These landscapes, shaped by catastrophe, not gradual change, reveal Earth's fundamental mechanisms. The narrative descends from continental immensity to singular wonders, where natural forces concentrate with peculiar intensity. The rift tearing through southern Siberia opened an abyss deep enough to swallow the Washington Monument 7 times over. This chasm, 5,387 feet at maximum depth, ranks as Earth's deepest continental lake, holding water equivalent to all 5 North American Great Lakes combined. The fracture began 25 million years ago when India's collision with Asia generated stress waves propagating northward. Unlike glacially carved lakes, Baikal occupies an active rift valley, widening 2 centimeters annually, an ocean in embryonic form. Water achieves transparency, exceeding 130 feet through microscopic crustaceans, filtering the entire column. Winter transforms the surface into ice architecture, 5 feet thick, creating frozen cathedrals where refracted sunlight fragments into cerulean chambers. "25 million years of isolation produced 1,700 endemic species. The Golomyanka, a translucent, scaleless fish birthing live young at abyssal depths. Baikal seals, descended from Arctic ancestors, now landlocked 1,500 miles from the nearest ocean. If Baikal is slow expansion, Putorana represents an instant catastrophe recorded in stone. Putorana is not a mountain that erupted. It is a wound that bled lava for 2 million years. The Siberian traps erupted 250 million years ago, extruding 720,000 cubic miles of basalt across an area larger than Alaska. This was a fissure eruption, cracks kilometers long, hemorrhaging molten rock spreading like floodwater, individual flows exceeding 300 feet thick. The timing coincides with Earth's worst extinction event. 96% of marine species disappeared. Subsequent uplift raised cooled basalt to elevations averaging 2,600 feet, subjecting it to erosional forces, carving 25 canyons exceeding 1,300 feet deep with fjord-like geometries. Over 25,000 lakes occupy over-deepened glacial basins, reaching 1,300 feet depth. Waterfalls outnumber those anywhere globally. Talnikovi plunges 2,300 feet in cascades, freezing into ice pillars exceeding 300 feet during winter. The plateau sits north of the Arctic Circle, creating light regimes where summer's continuous daylight transitions to winter's perpetual darkness. From a volcanic catastrophe that rewrote planetary biology, the path leads to sacred stone. The Altai rises where 4 geological provinces collide: Siberian Platform, Kazakh Shield, Zungarian Basin, Mongolian Plateau. This tectonic intersection built mountains reaching 14,783 feet at Belukha's double summit through orogenic episodes spanning 400 million years. Rock layers tell sequential construction stories. Precambrian metamorphic cores, older than complex life, lie exposed. Paleozoic sedimentary sequences record ancient seafloors uplifted into mountains. Devonian granite plutons intruded through older rocks. Approximately 1,500 glaciers occupy high elevations, carving U-shaped valleys, cirques excavated like amphitheaters, arêtes separating valleys, horn peaks where cirques intersect. The Yukok Plateau, elevated 7,500 feet, functions as a cold desert, receiving less than 8 inches of annual precipitation. Rain shadow effects create aridity comparable to hot deserts, yet temperatures range from -58 to 47 degrees Celsius, a 105-degree span among Earth's greatest. Permafrost preserves frozen burial mounds with intact textiles, tattooed human skin from Scythian civilizations, 2,500 years old. The limestone formations lining the Lena River constitute Earth's most extensive Cambrian carbonate exposures, stone columns reaching 325 feet, preserving the moment 540 million years ago when life learned to build skeletons. Formation commenced during the Cambrian explosion when seawater chemistry favored calcium carbonate precipitation. Skeletal remains of trilobites, archaeocyathids, primitive mollusks, accumulated in stratified layers on ancient seafloors. Mesozoic tectonic forces tilted these horizontal strata toward vertical orientations. The Lena River subsequently carved through the Siberian platform, cutting progressively deeper until exposing limestone deposited when continents possessed entirely different configurations. Weathering sculpted pillars over 2 million years. Water-penetrating joints exploited weaknesses, differentially eroding softer layers. Freeze-thaw cycles fractured rock mechanically, accelerating separation of individual pillars from parent cliffs. The stone preserves libraries of ancient life, fossilized trilobites entombed in limestone, archaeocyathids forming dense accumulations, marking ancient reefs. Surrounding Pleistocene deposits yield Ice Age megafauna remains. The Sunduki Range consists of 8 sandstone buttes rising from the Belly Eus Valley, red-brown formations reaching 650 feet, remnants of Devonian marine sediments deposited 400 million years ago. Ancient observers recognized that stone could serve as an instrument, that natural features could track celestial mechanics with precision, rivaling modern instruments. The buttes' geometry creates sightlines aligned with solar positions during solstices and equinoxes, producing an astronomical observatory operative for at least 16,000 years, predating Stonehenge by 10 millennia. High on cliff walls, rock engravings show dragon heads in one direction, snake heads opposite, shadow patterns moving predictably with daily solar cycles, functioning as natural sundials. The Temple of Time comprises formations, casting shadows, tracking seasonal solar movements. Petroglyphs depict astronomical notation systems alignment sequences corresponding to stellar positions, suggesting knowledge extending beyond calendar keeping to planetary motion tracking. Archaeological features densify the valley. Burial mounds spanning 3,000 years, irrigation channels, defensive walls indicating regional ceremonial centers. Olkhon spans 280 square miles in Baikal's central basin. Formed as a horst block crustal fragment elevated between parallel faults during the same tectonic processes, creating the Baikal Rift. Eastern cliffs rise precipitously, exposing fault scarps where vertical displacement exceeded 2,600 feet. Precambrian metamorphic basement rocks exceeding 1 billion years old form the core, overlain by Paleozoic sedimentary sequences. Shaman Rock, a marble promontory near Kujia village, protrudes into Baikal as a double-peaked formation with caves penetrating its base. The marble originated as Precambrian limestone, subsequently metamorphosed by heat and pressure during mountain building events hundreds of millions years ago. Differential weathering carved caves along weaknesses, creating chambers that indigenous Buryat peoples designated as dwelling places for Burkhan, a deity inhabiting the boundary between material and spiritual worlds. Waves break against marble cliffs, rising vertically from the lake, spray freezing into ice sculptures during winter at -40 degrees Celsius, ancient stone meeting transient frozen water. The Ergaki Range exhibits alpine topography created by Pleistocene glaciation, superimposed on a Paleozoic igneous basement. Peaks exceed 7,200 feet, with characteristic glacially carved signatures. Cirques, excavated by ice accumulation zones, arêtes separating valleys, horn peaks, where cirques intersect geometries, produced by ice erosion over tens of thousands of years. Precambrian and Cambrian metamorphic schists and gneisses intruded by Devonian granite plutonium through exfoliation and frost wedging. Alpine lakes occupy over-deepened cirque basins, dammed by terminal moraines, displaying characteristic turquoise coloration produced by glacial flour. Fine rock particles ground by glacier ice suspended in water, scattering blue wavelengths. The range's position creates a transitional climate where Siberian continental influences meet Central Asian weather patterns, generating temperature extremes. Winter, minimums below -50 degrees. Contrast with summer maximums approaching 90 degrees, a 140-degree span, among Earth's greatest. Vegetation follows altitudinal zonation, montane taiga below 5,200 feet, subalpine zones between 5,200 and 6,500 feet, alpine tundra above 6,500 feet. The Valley of Geysers occupies a 6-kilometer canyon in Kamchatka's eastern volcanic belt, Earth's second-largest geyser concentration after Yellowstone, containing approximately 90 geysers discharging superheated water into a narrow canyon where volcanic heat approaches the Gudin surface. The system originates from Kikpinik volcano, whose magma chamber at 500 meters depth heats groundwater to 250 degrees Celsius, well above boiling point at surface pressure. Velikan, the giant geyser, erupts with mechanical precision every 3 hours, launching water columns 90 feet high, accompanied by steam plumes reaching 900 feet. Individual geysers display regular periodicity, determined by conduit geometry and heat input rates, natural hydraulic systems operating with clockwork regularity across decades. The canyon contains diverse hydrothermal features, perpetually boiling pools maintaining temperatures near 100 degrees, fumaroles emitting continuous steam, mud pots, where heated groundwater mixes with clay-rich sediment. Thermophilic microorganisms colonize hot spring outflows, creating colored mats, yellow from sulfur bacteria, orange from iron oxidizing species, green from cyanobacteria. The syenite intrusions, comprising Stolby formations, crystallized 450 million years ago, when magma ascending from depth stalled before reaching the surface, cooling slowly to form coarse-grained igneous rock. This intrusive complex extends across 46 square miles near Krasnoyarsk, with exposed formations creating landscape features resembling gigantic sculptures reaching 330 feet. The rock fractured along 3 perpendicular joint sets as it cooled, creating natural divisions into rectangular blocks. Subsequent erosion preferentially removed surrounding weaker sedimentary rocks, leaving resistant syenite masses standing as isolated pillars. Weathering mechanisms, frost wedging, exfoliation, chemical weathering operated over millions of years, gradually rounding initially angular blocks. Individual formations bear names, reflecting perceived resemblances. Grandfather suggests a bearded profile. Feathers evokes wing-like structures. Lion Gate describes an arch formation. The reserve encompasses ecological transition zones where West Siberian taiga meets forest steppe communities. Siberian fir dominates mesic slopes, replaced by Scots pine on drier exposures and Siberian larch on north-facing aspects.
El archipiélago de Severnaya Zemlya abarca 37.000 kilómetros cuadrados entre los mares de Kara y Laptev, a 80 grados de latitud norte. Permaneció desconocido para los cartógrafos hasta 1913. Fue la última gran masa terrestre mapeada en la Tierra. A pesar de estar a apenas 60 millas de la península de Taimyr en Siberia, a través del estrecho de Vilkitsky, las islas pasaron desapercibidas por múltiples expediciones árticas que recorrían las aguas adyacentes durante el siglo XIX. La expedición Fram de Nansen de 1895 navegó a distancia visual pero solo registró océano abierto donde existía una masa terrestre sustancial. La expedición polar rusa de Toll de 1900-1902 también navegó a distancia visual, pero solo registró océano abierto donde existía una masa terrestre sustancial. El descubrimiento se produjo durante la expedición hidrográfica del Océano Ártico de Boris Vilkitsky a bordo de los rompehielos Taimyr y Baikal. La expedición inicialmente creyó que el avistamiento representaba una sola isla en lugar de un archipiélago de 70 masas terrestres distintas. Aproximadamente el 47% de la superficie del archipiélago está cubierta por domos de hielo que alcanzan los 965 metros en la cumbre del monte Karpinsky en la isla de la Revolución de Octubre. El glaciar de la Academia de Ciencias cubre 5.575 kilómetros cuadrados en la isla Komsomolets. Constituye la mayor capa de hielo de Rusia. Es un domo congelado de 819 metros de espesor que conserva registros climáticos de milenios en capas de hielo estratificadas. 4 islas principales, Revolución de Octubre, Komsomolets, Bolchevique y Pionero, albergan glaciares que muestran la morfología característica de un domo con superficies que disminuyen continuamente hacia los bordes. En los bordes, los acantilados de hielo desprenden icebergs hacia los mares circundantes. La historia de la glaciación de las islas refleja las oscilaciones climáticas del Pleistoceno. La máxima extensión del hielo ocurrió hace 140.000 años durante la etapa del isótopo marino 6. Durante esa etapa, las capas de hielo que se apoyaban en la plataforma continental del mar de Kara se extendieron por el Océano Ártico Central. Siberia emerge como un archipiélago de distintos escenarios geológicos que demuestran procesos planetarios a escalas de tiempo que superan con creces la cronología humana. El valle de Rift del lago Baikal ilustra la fragmentación continental. Los pilares de Lena exponen sedimentos marinos que preceden a la vida terrestre compleja. Las mesetas de basalto de Putorana registran volcanismo en flujo coincidiendo con la peor extinción de la Tierra. Estos sitios funcionan como laboratorios naturales donde los mecanismos fundamentales de la Tierra permanecen visibles. La permanencia sugerida por la piedra resulta ilusoria a escalas geológicas. Las montañas se elevan y erosionan, las cuencas se hunden, las especies desaparecen. Lo que persiste son los procesos en sí mismos, fuerzas tectónicas que fracturan continentes, sistemas volcánicos que liberan calor planetario, meteorización que reduce montañas a sedimento. Proteger estos paisajes preserva información esencial para comprender el funcionamiento planetario.